We have less people already, or I am dreaming this? I think there is people in the internet. I'm not here in the internet, so if the internet want to say something, please, I need somebody to tell us. I think there are 4 or 5 people. 12 people. Online, 12? Oh, wow, okay, let's gonna see how this is working. Remember that we are super okay with the people being online, but this is a lot of experimentation, okay? So I highly suggest that you come here because we are going to be doing a lot of stuff hands-on, and if it's failing or you're not able to reproduce and you cannot ask, it means you're not going to learn it, and then you're not going to be able to do the same in the exam. We didn't talk much about the exam, but it's going to be highly practical, which means you should be able to do it, okay? Whatever you do here, type and touch the computer. Even if you're in Teams and you're sharing one computer, do not leave the class without trying the commands, because in the exam, okay, I'm talking about exam. I'm going to say exam is practical, it's hour and something, where you have to solve a lot of tasks like CTF style and getting the flags. The problem of the exam, it's not so much about the technical complexity. The technical complexity is going to be the same as in the class. We are not going to be asking you to do stuff that you didn't do. The problem of the exam is the time. If you go to the exam without practicing and without knowing, you are not going to have enough time to do that. It's a lot of stuff to do. Okay? So believe me when I say the only way to approve the exam is to practice and to have this at home and here. Then you go, you're fine. If you go there and you start searching online what is a port scan, you are not going to be ending on time, okay? So that means practice, practice, and practice. So please, people on the internet, practice this at home. So I want to start saying that for the new people, I think that we have new people here. I want to wait for Georgie a little bit. So that we have the infrastructure of the class. It's Microsoft Teams, so you should go there because in there we chat, and you can ask here stuff in real life, but also you can chat us there. So please ask. In real life or chat, ask. We are going to be answering. We also have teams of 2 people, and it's mandatory to have teams of at least 2 people. Nobody can be alone, okay? So if you do not have a team, another person to work, now is the moment. Human interaction. Go and say, hi, I don't have a team. Go to the chat and say, hi, I need some partner or something, okay? You need to have some partner. And we are going to be doing the whole class in Teams, and you're going to be assigned a Docker, and you're going to be SSHing into the Docker and doing everything from there, okay? And remember that the Dockers may reboot because live. So whatever you do in the Docker, captures, installation of files, be sure that if you lose it, you don't lose everything, okay? So make backups, keep the stuff also in your computer, okay? Something more? Yeah. You all right? We are super okay? Okay, so let's start. Laboratory class 2, finding computers to attack and services, aka be like Trinity, use Nmap. Of course, Trinity and in Matrix 2, where she's using Nmap to hack, and we were super happy to see her doing that in real life and say, yeah, go Trinity. Real life, that was real life. And by the way, she's also using SSH exploits that were also real. Correct vulnerability, so it's very nice movie. So you have there the link to the documents. We have some survey results from last week. Thank you very much. Everyone was giving feedback, saying if it was too fast, too slow, or all right. Most of you said all right. Some of you say too fast. I'm going to try to be more clear when I'm speaking because of my Spanish accent. Please, if you don't understand, ask. But we have kind of an amount of stuff that we know you can learn in this hour and a half, so we are going to try to give it to you, okay? So I suggest that if it's too fast because you don't know some concepts, you can ask us and you can learn, and the rest is like being in focus, okay, everyone? So, Pioneer Prizes. We have the first Pioneer Prizes of the week. The Pioneer Prizes, you remember, the first one to solve the assignment of the week. In this case, we are going to first show the prizes. And the prizes are, for the first team, is going to be chocolates for the team called // What is // Congratulations. There you go. Welcome. Congratulations. This is for you. Enjoy. I think we have enough pieces for all of us. It's like 80 people, so don't worry. And then the second place is going to be this nice book, ebook, not paper book, ebook, The Practice of Network Security Monitoring to Prague them all. Prague them all, there you go. Congratulations, Prague them all. And the third place is going to be to Linux Pocket Guide to Team 16. Team 16, what is it, Team 16? There? Oh, there you go, congratulations. And if you want to change your team name, you cannot anymore, so that's it. So, let's go to our thing, getting ready. Internet, are you there? Yes, right? Everyone is in here, perfect. So we are going to be starting by capturing traffic in your Docker because we want to get all this together, okay? All this together. And remember, you can get together with somebody for today. So remember, today is about, we need somebody here that is willing to share the notebook for today, saying, look what I'm doing, I can do stuff for you. Who is willing to share with? Marek, are you here? Okay, who is willing to share and look at the notebook together with, how was your name? Marek. Oh, okay, another Marek. So, we need a volunteer. Come on, people. There, we have there a volunteer. Thank you very much. Oh, he's coming to you. Look at that, so nice. Yeah, so at least you can see everything happening. Sorry? You need one. No, but this is about the computer now. So he needs a partner because he doesn't have access to the Docker. Is a team willing to incorporate him for today only and to show access to the Docker and work? Which team is willing to take him by their side? He's promising chocolates. There you go. You have somebody that you can share. Thank you very much. OK, so let's go to our thing. We are going to be capturing packets now because later, I'm not sure when later, probably next week, we are going to be analyzing this pickup file. So remember, the pickup file is a file where we store all the packets going into the network, OK? So the first thing we are going to be doing is connect to your Dockers. And we are going to be running this command. This command is tcpdump. tcpdump is the de facto tool for capturing packets. tcpdump goes to an interface, read the packets, and show the packets in the console, OK? So we are going to be doing this command. I will copy paste here in my Docker right now. If I didn't lose, I lose internet, so wait for me. There you go. Because I disconnect my, yeah. So I'm going to be putting the command in my Docker, and you should see something like that. Do you see that? That means packets in your network, OK? tcpdump is one of the best tools to go and see what's going on in your network. We are going to be analyzing this. Don't worry. Now I just want you to see that you have something.
Is everyone connected to the Docker?
Yes? Perfect.
Yes.
Or raise your elbow. So tcpdump, what does it mean? The /n means do not resolve host names. So every time that tcpdump finds an IP address in the network, it's not going to try to use DNS to get the name of the IP address, OK? And we don't want this because it's creating traffic from your computer that we don't want. We just want to listen to traffic. We don't want to generate. And second, because sometimes when you're analyzing malware or real attacks, those are IPs that sometimes belong to attackers, real attackers. So if you do a DNS resolution of an IP of an attacker, you're actually connecting to the attacker, which is not a good idea. So in general, we say, hey, tcpdump, do not resolve the host name of the IP. Then we have -S0, which means for each packet, I want to capture the complete payload. 0 means infinite, everything. Because if not, you can say, OK, only show me 10 bytes or 20 bytes or 30 bytes. Usually, we use this one. And then -I means the interface. In our case, we are going to be using the Ethernet 3, ETH3 interface that is the default in your Dockers. If you are using Mac or Windows or Linux, you will have another names, OK? Everyone good so far? Perfect. If you saw my command, there is a lot of traffic because I'm now connected with SSH to my Docker. I don't want to capture my own traffic. I want the traffic that it's not me. So how do we do that? And for that, we need to exclude our IP address from this traffic. And for finding the IP address that you are using right now to connect to your Docker, we are going to use this magic in here. So copy paste this magic, magic number 1, and that's going to tell you the IP address that you as a client are using to connect to the Docker, OK? If you want to know how this is working, the netstat command is giving you all the connections happening in your computer, and these are the connections to the Docker. You see port 22, establish SSH connections, and the IP addresses of people connecting to this Docker. OK? So what we are doing is just extracting the IP address from this command. Not super important, just for you to understand how to get your IP address. So what are we going to do? We are going to be starting a TCP-DAN command, the same -n, the same S0, the same Ethernet. We are going to say beep verbose. I want to see a little bit more stuff going on. We are going to now say -w, which means store, write the packets in a file. That's the W. And we are going to give the name of the file, /tmp/capture. And if you pay attention, you will see a format directly in the name. So TCP-DAMP is a little bit smart. And it's like, oh, you want a file, but you want me to change that for the real value. So every time that you write this command, it's going to put the real year and month and date in there, OK? .pcap. Then we are going to say /l, which means do not buffer the packets, just write them there. And then we are going to say capital G for the rotation of the file, which means this amount of seconds you should wait. And after that amount of seconds, you should actually create a new file. And that means 1 day. Oh, somebody tried to delete the command, but I will stop it. So that means wait 1 day, those amount of seconds, and then create a new file. OK? So every day, you will have a file pickup with the traffic going to your Docker. And most importantly, we are going to be using the host parameter. This is a filter. And we're going to say, hey, TCP-DAMP. I want you to store all the packets as long as the host, the IP address, it's not, ! It's not some IP I'm going to give you, OK? And at the end, we are going to say ampersand. Somebody know what is the ampersand at the end? Linux users? Run it in the background. So I don't want this consuming my console. I want to run this in the background. And the nohab beans store the output in a file. And I'm going to also stop you for modifying and also stop you from modifying. There you go. OK, so let's going to copy this command. I'm going to copy it here. And I'm going to change your client IP address by the IP address I saw before. So my IP address was, OK, I need to run it again. Oh, where is it? This one? Oh, sorry. This one. And now I'm going to be running in this again. So if you look at my screen or you're doing in yours, that's the complete command, OK? Nohab, TCP-DAMP, NS0, Ethernet 3, verbose, right here, wait 1 day, not me. OK? Pay attention that if you go home and you connect to the Docker, it's another IP. So you have to modify the command. Also, please check this file, because if they get crazy big, it's going to try to eat the hard disk in our server, which means we are going to have to delete it. So if you have a file that is something like 1 GB, we're going to say, literally, we are going to write that. OK? OK, now that we have the file, we can continue in our exploration. Yes. Yes, no problem. We can have a minute right now. I will use this for taking questions.
Can you stop
Yes.
the camera in Teams?
Oh, yeah.
Recording you.
No problem. Thank you very much. Is that better? And now should be recording the document only, right? Any question from the internet? No? Question from here? Everybody, please be sure that you're running your TCP dump. Do you want to, to check with Vero? Yeah. Everybody running TCP dump. Also, you can monitor the size of the file. Yes, everyone here? Yes. To what? To bring? To print.
I got
Oh, okay. So yeah, that's the when you run it and it's in the background, it's like printing you some information, but that's super fine. If you want to check if the process is alive, you can do a PS AFX. I will show you. Oh, that one there. And that should show you that the TCP dump is running as a process, okay? Just be sure. Is it working? Okay. It's who is having Docker issues, connection issues? There? What does it mean? You cannot SSH? Okay. Okay, I will give you. Yeah. Honestly, today the CVUT had some internet issues. I'm not sure if you noticed. Everything was super slow. So.
you didn't distribute the end.
Oh, yeah.
You haven't talked about it yet.
Yes, true. The rest is okay? You can try the other commands while you wait too. Here. And you're touching the computer. Oh, well done. They're good. Here. And your partner is online? Your partner is online? Yeah. Okay. Virtual Teams. The rest? Okay. Here, yes. Can we continue? Okay. So if you want to see if your command is running, you can do this PS, process listing, while you are doing AFX, the parameters for all the processes, and then you are going to be grepping for TCP dump. Remember grep. Is black the best for you, or do you want white background? It's OK, perfect. So grep is a pattern matching search engine, let's say. So you can say, hey, grep, I want you to find in all the output for PS, right? In all the output, I want to search the lines that says TCP dump. I have 2 there, OK? If you want to kill the process, you can kill with this command if it's a command you execute in your console. And if not, you can also use kill with the PID, the process ID, right? If you want. And lastly, if you want to copy from the Docker to your computer, you can use a command like this, and then you can bring the pickup back to you, OK? So we we'll move into the next step, that is the penetration testing methodology, that is the basis of this class, okay? So if you remember, the class is going to be one class about attacking, this class, the next one about defending. Attacking, defending, attacking, defending. This is because we are following kind of a generic penetration testing methodology. Somebody here is working as a penetration tester? No? Somebody knows about what is a penetration test? No? Somebody knows somebody that knows what is a penetration? I don't know. I ran out of options. OK, so a penetration test is a security test that, as an analyst, you want to get inside a computer, system, organization, or building, or whatever thing you are hired to get into. Includes things like security vulnerabilities on the internet, but also in the Wi-Fi, RFID cards to open the doors, getting into buildings, lock-picking on a lot of different things. So this is a methodology that we are using since the 70s, roughly, where we attack completely an organization as an attacker with the attacker's tools, and we try to get in, and we are paid for this. And it's a nice job. It's very refreshing because you are attacking you are being paid to attack as much as you can. Several companies actually here in Czech Republic are doing this too. So we are going to be following this methodology in the complete class so you have an idea what's going on and how to do it. This starts with documenting all the process. If you do not document all the process, you cannot generate a report, which means you have no idea what you did, which means that you are not going to get paid, and in this class, you are not going to get your grades. So you need to document everything that you are doing, right? Second, you need to define your goal. Penetration testing is huge, and some companies are focusing only on the web. Some companies are focusing on specific branches, like the branch in Honolulu. Some companies are focusing on new technologies, like maybe, I don't know, WPA, Wi-Fi. Some companies want to focus on checking the code, like looking at the code. So it's very important that you define what's going to be your goal. So every class, we are going to give you different goal, like, oh, detect malware, detect an attack, detect a vulnerability, exploit something here, or get some document, or exfiltrate data, or we are going to be creating malware at some point. So it's very clear that you have this in mind. In particular, in a penetration test, it's very important that you have the range of IP addresses and domains and addresses, physical addresses that you need to test, because you are hired to test a specific range. If you do one attack outside the range, you can go to jail. So this is like very important limit to have in mind, right? So when the people say, oh, I want you to test pepito.com, you test pepito.com, not pepitito.com, okay? Third, you recognize the attack surface. It means you go there. I don't care if it's the internet, Wi-Fi, or physically, and you need to map everything you can attack. So it's like, oh, I can attack the DNS servers. I can attack the 3 Wi-Fis that I can see in the building. I can attack maybe phones that are there. I can attack 3 web pages. I can attack 4 FTP servers. And I can attack the phone number of the manager, whatever, right? So you need to map the surface of attack. This is what we are going to be doing today, okay? Today, we are going to be mapping the surface of attack. Then we are going to identify the infrastructure. This means like which computers, servers, routers, DNS, domains, mail server. You have to make a list of everything that you are going to have in your test. After that, you need to identify the service, which means, oh, this is an Apache 4.3.1 in macOS. Oh, no, this is a cloud service. And this is an Amazon instance B3 something. And this one, so you need to very much identify the versions. Does anybody know why the final version is very important to identify? Very well. So, wait. Marek. Milan. As Milan was saying, the final version, usually you can search for vulnerabilities. So if you know that this is FTP D1.1.3.7, then you can be more precise in your attacks, okay? Then we are going to find vulnerabilities. So you're going to go and check what's going on. Like, can you force something in the web? Can you force some sending of an email that should not be sent, right? You are searching for vulnerabilities yourself. Then you plan the attack, and you attacked. And then you gain privileges. You mean that from a user that it's not admin or root, you need to gain more privileges. You are nobody in the system, and now you need to be the administrator. And this is so you can actually do more things in the computers. So we call it also like gain privileges or elevation of privileges. Then you have to gain persistence, which means you need to keep access to that computer even if the people wants to take you out. So the moment you get in, you say, well, how can I keep access to this computer when they fix this vulnerability? So you maybe put a backdoor, another malware, reinstall something, put a new user, change the I don't care, something, okay? So gain persistence. Then you try lateral movement, which means jump into another computer. Maybe you can go to the router, to the domain admin. Maybe you can go to a laptop of somebody. Then you try to exfiltrate data, copy stuff out, because that's why you're there. Maybe take the database of passwords, or maybe the code, the source code of somebody. Then you hide, finishing everything, and you report the results, okay? This is the methodology we are going to follow. Quick questions. What's the difference between a real attacker and a penetration tester? The penetration tester has the out-of-jail free card. And I'm going to repeat this for the recording. True story, when you have a contract, you usually have a get me out of jail free card that if you are caught doing this, you show this usually to the police or to some security people, and you are not going to jail. Usually. No, you are not going to jail. Yes, that's one difference. Another difference? The attacker doesn't need to report anything. I would say that most of the time that's true, used to be true. Now, there are such a big gangs of attackers that I'm not sure. Maybe they still need to report to somebody. But yeah, usually they don't need to report to anybody. True. What else? Huh? Purpose. What about the purpose? Uh-huh. Yes, and the attacker? Okay. It's a deeper purpose for an attacker or a shallower? It's like more complex or less complex? It's more complex. Well, I would say that for the attacker, sometimes the attacker is like, I just want to take this down, DDoS, and that's it. Or sometimes it's, I want the source code of something. So it depends. Sometimes it's super hard, the purpose, because it's like government hackers or these warfare groups of hackers hacking for some country. It happens, it's true. So yeah, there are different purposes, I agree. In the case of the penetration tester, you have a goal, you have to test, and bye-bye. Another difference? It's paid less. I'm not sure about that. So I'm not sure. It depends. Penetration testing in a normal company pays very well. Very well. You can go and ask. And usually we believe that attackers have a lot of money. But we found several reports, and in Stratosphere Live, we did a report in underground attackers owning a botnet, and we actually saw them typing in a private chat, talking about, I want to create this malware, and then I have to pay this, and okay, pay me because I do that. And the amount of money was very low. And actually, they were saying, hey, I want out because, it's a lot of work, and it's not paying off. I said, no, the money's coming. So we learned that actually we have the movies in our head, but the majority of the people is struggling a lot. So, but there is a difference, yes. Okay, so somebody more? What about the time? As a penetration tester, you have usually a week, maybe 3 days, usually, maybe 2 days, and that's it. You have to move on. You do 3-4 days, a week, you test everything, You found or you didn't find something, bye-bye, next client. The attacker can be attacking the whole year. The attacker actually will attack during Halloween, during Christmas. They can do this every day, which means that they have much more opportunities and probabilities of getting in, okay? And also they see the company changing in time, which the penetration tester usually does not. Okay, so penetration testing, questions so far? Internet, questions? Let me check. Oh, sorry? It's fine? Docker issues? No? Perfect. So write down what you do and the results. It's important, please. I'm pretty sure everyone already wrote down in some log that we execute the TCP dump already, so you know where this is happening, right? In particular, I want to say that when you're attacking and you get into a computer, one of the suggestions we do is like, try not to repeat the commands, which means if you are doing a cut of a log that it's 3 megabytes, you don't want to do that twice, because if you start repeating commands when you're attacking somebody, there is more probability that you're going to be found because you are sending more data. So one of the things we do when we get into a remote computer is actually completely copy the content of your screen to a file so you don't have to repeat commands, okay? Don't worry, we are going to be there. So before doing the port scan, today we are going to be starting with port scan. Do you know what is a port scan? Somebody knows what's a port scan? Port scan, there we have something, yes, yes, don't be shy, yes, yes, super. Is it legal to port scan a computer? Ah, that's a voting? Okay, so who thinks it's legal? There you go. Who thinks it's illegal? Okay, who has no idea? Oh, what? Very well, Georgie? Very well. It depends on the country because, okay, in two ways. First, legal or illegal means according to the laws, which means laws, like in paper laws, like somebody doing the law. So if there are no laws, it's legal, okay? A lot of countries still don't have any law about this. In those countries, whatever you do, it's fine. Second, when you are attacking some computer, imagine that you are here and you are attacking very far away remote computer like in Argentina. So you go and you attack. Is it legal or illegal? With a port scan, right? All the time with a port scan. Hi? Legal or illegal? Illegal. Somebody else? Yes, if I'm scanning from Czech Republic, a computer that is in Argentina, is it legal or is it illegal? Exactly. So maybe in Argentina, we have a law saying, no, you cannot, imagine, you cannot attack computers in here, like US, like in Czech Republic. You have a law saying, no, if you attack a computer in Czech Republic, this is illegal, you go to jail. But if you're in Czech Republic, you're not attacking computers in Czech Republic. You're attacking computers there. And no law says that from this country you cannot attack another country. It's like very weird, like nobody says that. So actually, if you are in one country and you attack or port scan another one, in that country it's not illegal. No country on earth is doing that. Mainly because the government is attacking others, but that's another story. In the country that is receiving the attack, they have a lot of laws, and in some countries, I don't know, maybe North Korea, it's super illegal to do a port scan, I have no idea. In the majority of the countries, doing a port scan, it's not illegal, because it's a way to go to see how many ports you have and interact with the ports. The ports are open, you are opening them, and they're public in the internet, you are not breaking anything, so port scanning, it's not illegal, okay? That being said, it doesn't mean that it's not dangerous. A lot of port scanning can take down computers because you're sending so many packets so fast. So just be careful when you try this, like in the production server in the office, that you can take them down, okay? So reconnaissance is the first step, so let's do Nmap. I lost the timer, so you tell me how it's going. Nmap. Well, so what is Nmap? Nmap is a free open source tool. It's a network scanner created to discover hosts and services in the network. It's one of the most important security tools we have in the network, can do plenty of stuff. It's crazy amount of things you can do. And actually, it's a tool that we are going to be using a lot. So, and in here you have a cheat sheet, so you can go and get the PDF with a cheat sheet of commands. And also, my awesome team was good enough to print the cheat sheet, so you have here for free some cheat sheets, and you can go back home with a bus learning about Nmap. Nmap is crazy big, has thousands of parameters and commands. We are going to see some of them today, OK? So, first steps, how to know if a computer is up or not. So what do you say? How do you know if a computer is up? You have a computer, and you have another one. Sorry? Do you agree? Everyone agree? If the computer is not, how do you know in the network if another computer is up and working? And here, how's your name? Vasek says, if it's not answering, responding, I know it's not up. Which message? Error message. So what you're saying is that somehow we get some error. Sometimes you can get that, sometimes you cannot get that. So OK, so you're saying I'm sending more technical, an ICMP packet, and something is going on. How do you know what the computer is running with ICMP? But how do you know what the computer is running? Do you mean operating system? Or do you mean if it's up or down? Oh, perfect. So one technique, you send ICMP echo request, which is the ping. And if you have an answer back, you say, oh, you're answering, you're up. What if the computer is not answering, like Vasek is saying? Do you say that it's down? No. Exactly. You don't know, right? OK, so we have many techniques. Sometimes the computers are filtering this and not answering to you. So we are going to explore the options. The first technique we are going to be doing is ARP. Do you remember ARP? What is the purpose of ARP protocol? Map? No. It was too low, right? Sorry. Oh, thank you. Mapping. Mapping IP addresses to physical addresses. Do you agree with Milan? It's not searching. You are sending the packet, and you get answers, right? It's not like a database or something like that. Sorry? But you don't have the list, right? So ARP, you send a packet, and you receive a packet. In the protocol, there is no list, right? Yeah. OK, so it's similar to what Milan is saying. OK, I have an IP address, because imagine that you know the IP address of some computer. I say, hey, I want to connect to this IP address. So remember that any packet, all packets going into Ethernet need 4 values at least. Source IP, source MAC, destination IP, destination MAC. If you don't have some of these, you need to get them. Source IP is your IP, you know that one. Source MAC is your MAC, you know that one. Destination IP you have because you are typing. Destination MAC, no idea. That's why you use ARP. ARP is say, hey, who has this IP address? You can do as Peter Jakub says, you can do a broadcasting, which means I'm asking all the computers in the network, hey, guys, who has the 192? And then someone says, oh, yeah, I have it. This is MAC addresses. And then you have the MAC address. Can be some attacker in the middle, yes, but we are not going to go there. The other option is the reverse, is I have the MAC, I want to know who has the IP of this MAC, the reverse, okay? Sometimes you have the MAC address and you need to know the IP address. So we are going to be using this protocol, not because we care about the MAC, but because we want to know that the moment you are answering me with an IRP, it means you are alive. So if you copy this command in your computer, and you press enter, you're going to have results. Do you see this? Everybody? Yes. We are going to explain everything now. Do you have results? Do you see something in your screen? OK. So what's going on in this command? nmap -sn means do not scan ports. Do not scan ports. OK? -n, do not resolve DNS. -v, be verbose. And then we are using a network address, which means we have some IP address, and then we have in CIDR notation the description of the network range we want to scan. Do you remember this notation from your network class? Can somebody explain to me how does it work? Which one? Oh, sorry, this one. So if you remember exactly, in IPv4 we have 32 bits, and those 26 is telling me, like, who was saying? I don't see who was talking. Oh, there. So, and Pablo. Huh? How? Philip. Thank you, Philip. So Philip was saying the first 26 bits of those 32 are for the network. So fix them. Those are the network. The rest of the bits, you can move them to change and have access to the hosts in that network. OK? So if you do /26, it means some computers, I think like 30 computers or something. So it's not the complete range, OK? Bonus question, which IP address, or what does it mean, the IP address 172.16.1.0? What about the 0 here? The network, do you agree with Georgie? Yes, everyone? Perfect. What is .255? Broadcast of that network. So 1.0 identifies the network like an object. The .55 identifies everyone in the network. That is different. OK? OK, so in here, if you see the results, nmap is running. I'm going to go up until nmap starts and saying initiated our ping scan, and then scanning 63 hosts, and then completed the ping scan, and it's telling you one by one. 1.0 is down, 1.1 is up, and this is the MAC address, and then 1.2 is up, 1.3 is up, 4, 5, 6, 7, up, and then finishing with the reports. All of these ones are down, and there are in total 41 host ups. OK? Everyone? Perfect. Now, anyone could not run nmap? Issues? Problems? No? OK. Yes? Yes. So it depends which tool. I would say that for me, nmap has, I don't know IP scan, but so nmap has like 25 years of history. So actually, the group in nmap developing actively took decisions even to change the protocol. So the people doing nmap is like crazy good, right? And also they move from only scanning ports to be a very performant tool. So if you want to scan hosts in one computer and you want to see what is there and the versions of the services, nobody does it better than nmap. The amount of fingerprints that they search for finding operating systems in the community is like unbelievable, right? Sorry? accuracy, speed, performance, amount of modules, scripting is like amazing, right? There is only one thing that they're not the best, that is finding one port in many computers. There are other tools like Mascan or ZMap that they specialize in many computers, one port, and they're faster, but because of some technique. But Nmap does not want to do that, yeah. So, but it's crazy good. So, after that, now what we want is not to use ARP. We want to actually force to go into the IP layer. We want to actually send IP packets. And that's can be done by using send IP. So send IP, it's a very similar command. You can go and try, right? Please run it in your computers. And it's going to go to the network, and it's going to find 41 hosts. But it's not sending ARP packets. It's sending other packets. And this is because when you are doing ARP scan, it's much more stealthy. Actually, few tools can detect this type of ARP scans, few tools. And if you're in the local network, this is the way to go and attack, okay? ARP, super good, super fast, nobody will notice easily. But sometimes this is blocked, or you cannot do it, or you're in a different type of network, you need to force ARP. So, to see what Nmap is doing, we can go and check the network traffic in your capture file, but better, we can actually run the command, adding at the end packet trace. So I'm going to do packet trace, and then I'm going to do pipe less. So I'm giving the output to the less command, that is doing a pagination, pages, showing in pages the information, okay? So if you do that, we are going to be looking at the internals of what is Nmap sending in the network. So for now, we are going to start. And can somebody tell me which is the first technique the Nmap is trying by default in the network? Now that we are saying, hey, Nmap, just send IP packets. Get crazy. Do whatever you know to find computers up. It's there. It's now in the screen. ICMP. So it's saying, hey, Nmap is sending an ICMP, echo reply. Well, echo reply is the one going back. Oh, that was so fast, Nmap. Well done. Let me refresh. Oh, there you go. Echo request, we are sending this, type 8 code 0. That is, if you remember an ICMP, you have types and codes inside those types. There are like 16 variants or more. One of those is the echo request, and then we are sending this to 1.1, and then echo request to 1.3, 1.5, 1.8, and some of them I already replying. Oh, you get from an echo reply from 1.1. This is the ping technique, very useful, working, and Nmap is using it. One technique done. Can you see other technique that is not the echo request technique in there? TCP, which one? This one. So this is Nmap saying, hey, computer 139, port 22. What is 22? SSH, the secure shell. And it's sending what type of TCP packet? Well, it's sending a packet with the ACK bit. Remember the flags in TCP? Maybe we didn't talk about it. So remember TCP, you have some flags. How many flags? Yes, in the TCP header, in the network protocol, you have some flags to identify the different things you can do with TCP. How many do we have? 8? 8? Here, wait for me. It's not Pavel. Jakub. Jakub says 8. Do you agree? Do you concur? No? Somebody gives more? Less? So it used to be 6 at the beginning of times, 1960 something, and then we got crazy and we had 2 more, 8, and now there is a 9. Yeah, nobody matters. We use 6, so forget about that. Yeah, they're proposing. So 6, do you remember them? So 1 we already know very well in the handshake of TCP, it's the SYN packet. I will give you this one, SYN bit. There is a bit. If you put it in 1, means I'm synchronizing with you. What other flags we have there? ACK, SYN we have, ACK is the second one, that's one. The acknowledge, when you put the acknowledge in one, means this packet is acknowledging some data sent before. So we have two. What are the rest? Reset, if you put this bit on, I'm finishing a connection emergency style. Reset. Fin, if you put this bit in one, it means I politely want to stop this connection. Let's please talk about it. It's like a mutual understanding breakup, let's say, right? Fin bit. What else? Push, very well. A push bit, when you put it in one, means that you are getting data and sending it to the network. Details, it doesn't matter, but you are telling the operating system, send this now, don't wait. And the last one is urgent. In 1970s, we wanted to tell the operating system that this piece of data was urgent and the other one can wait. And we have a bit for that. What a waste, right? Nobody's using it. But it's there, and we used to use it a lot. OK, so that's the ACK bit, which means, oh, I'm sending you a packet with an ACK bit. What do we expect here? What is the expected behavior of this connection? So let's go into the fascinating topic of how to know if a port is open. So it's acknowledged of what? And why we are seeing that? Sorry? Is it open? OK, that was a very nice catch, because that is a packet belonging to my SSH connection, not to Nmap. So Nmap is making the confusion of the packet because I'm using the same computer to scan and to connect. OK? So well done. That is part of an ongoing communication between me and the computer. OK? Everyone got that? We are receiving the packet. We are not sending it. OK? Anyway, we are going to be looking at that technique as a port opening technique, OK? So keep it in mind. So we have the request, the replies. We are going to be now looking at the ACK technique. These are receives. What else? What else we have? I will move down. Can anybody spot the next technique? Which one? This one. And what is this? Is the initiation, is saying, hey, SYN, I want to connect with you, port 443. What is 443? HTTP, no, but it's close. HTTPS, TLS. So let's go into how to know that the port is open. So you have a port in TCP, OK? And I'm sending a SYN packet. If the port is open, which means there is a process listening, what I am getting back? SYN ACK, OK? I'm sending a SYN ACK. This is a process of the normal handshake. I'm expected to send an ACK back and send data. So what happens if the port is closed? There is no process listening in this port. I'm sending a SYN packet. What do I get back? Nothing, say Milan. Do you agree? Yes? It's not correct. Somebody else? Huh? No firewall, only the port is closed. There is nobody listening in the port. Huh? connection reset rejected. Yes, we have a reset back. So if you send a SYN and the port is open, you have a reset ACK actually, because you acknowledge that I tried to connect and then you reset the connection. So if you have a reset back, a reset ACK back, the port is closed. What happens if the port is filtered? You have a firewall now. It's completely firewalling. Which means times out. If I'm sending something and there is a blockage, a router, a firewall, or whatever, time out. So that means that I can send packets and I can see the state of the ports doing this. We are going to be doing this later. For the purposes of this exercise, which means is the host up, we don't care. You are sending me something, SYN, reset, whatever you're sending, it's good for me. The first packet I receive from you, I know you're up and working, okay? So why the port 443? Why Nmap chooses this port to connect? Very well, Jacob. It's one of the most common open ports on the whole internet. And this is why Nmap is using it, because the probability of having that port open is very, very, very high. Okay, so Fing, yes, go connect. So these are the techniques, and it's doing a lot of these techniques. You can see, for example, another one here, the ACK technique, okay? The ACK technique is similar. We are going to be looking at that, but the ACK technique is if the port is open, what happens if I'm sending an ACK packet? It's open. So I send an ACK packet. I'm not talking to your port. Jacob said FIN packet. Do you agree? Somebody else? So the situation is there is a computer with the port open. I should, by protocol, send a SYN packet. We are hackers, so we are not sending what we are supposed to send, so we send an ACK packet. What is the answer? I don't care if there is somebody already talking with the port. I want to provoke a reaction from the computer. So I'm sending an ACK, and if the port is open, it's going to tell me reset ACK. What you doing? It's like you're sending stuff that I don't understand, out. And if the port is closed, reset ACK anyway. So it doesn't matter the state, except filter, I'm going to get a reset ACK. So why are we sending the ACK packet? Why we are not sending the SYN packet? Isn't the same? Well, not, but the reason is that a lot of firewalls only filter SYN packets. So it's, oh, you can connect to the computer behind me only if you send the SYN packet. But if you send other packets, they're like, okay, wait, I'm not sure, you know, ACK is nice, you are probably talking, because I'm not the same computer, so I don't know if you are already talking with the computer. So, maybe, so a lot of firewalls let you go through, and you can test the ports even with a firewall in the middle, okay? Okay, so let's continue. A lot of these techniques we already saw here, so we are good with them. You already saw ICMP, this is super good. We actually can try different styles. So this is the ping, the ICMP echo request, and this is a very special one that it's called, with Q, you can get out of less. This one actually sends a packet. Oh, sorry, I will put the packet trace so you can see. Pipeless. In this one, I'm going to send a very special ICMP packet called address mask request. What? It's like a very weird, nobody uses it anymore. But the protocol says that if you are enabling this in your computer, you should answer me. So this is a very sneaky way to actually find if a computer is up without touching ports, without touching TCP, without touching the firewall and anything. It's very, very hard to detect. The next one is actually calling something called the timestamp query, which means, oh, sorry, I'm going to also do the packet trace. So in the timestamps request, I'm asking the computer, oh, sorry, can you give me what time is in your computer? For whatever reason they were using this one. And then the computer is saying, oh, yeah, it's like 5 o'clock here. So Fine, thank you. I know you are up. And actually, look at this. This is still working a lot in a lot of computers. Oh, wow, that was... So now is the movie. No. So the other techniques are using ACK, like we already saw this one. So there is like... Yes. Oh, I skipped that one. Oh, thank you very much. So Honor is telling me, hey, you forget the UDP. So let's see in UDP, right? So what's going on here? Let's try UDP and see what are we doing. Actually, we do P, capital U, and that's UDP. So what's the purpose of this? Huh? Yes, what is the purpose of... Okay, several purposes. Why? Why are we scanning UDP? Well, because there are services in there, and we want to find them, right? So can you remind me how many ports we have to scan? How many ports are there? No, I want the number. 65,000? Huh? I want the exact number. 65,000... 537, 6, 5, 6, because the port 0 exists and works. So from 0 to 55 is total 36. But that's not true, because this is only maybe in TCP. What about UDP? We have double the number of ports. So when you scan the computer, we have TCP and UDP, not to mention a CDP. Be careful, because in the exam and in different assignments, stuff is going to be all over the place. So be sure that you know how many ports are there to scan, OK? So going back to UDP, we are scanning this port. What is that port? Somebody knows that port? 40,125. Nobody knows. I don't know it. It's nothing. It's a very high port. Why it's a very high port? Why we are not scanning a very common port in UDP, like 161 or something like that? Come on, play with me. Why we are not doing that? In TCP, we were choosing a very common port to increase the probability of the port being open, so we have an answer. In UDP, we are choosing whatever. Oh, that would be nice. Oh, OK, nice answer. Not exactly, but nice answer. Milan is saying, well, if somebody left all the ports open and we found that in there, we are going to have an answer, which is nice. And if you find a port like that open, it's kind of nice, right? But this is not because of that. This is because in UDP, how do you know that the port is open? Let's go and play again. I have a computer with UDP. So I send a UDP packet, which flag? There are no flags. Well done. Tricky question. Well done, Milan. So no flags in UDP. So you send a packet empty or with data. Who knows? So you send something. What do you expect if the port is open? Nothing. Thank you very much. And if the port is closed? Yes. Well done. So no, not nothing. Sorry, what? Status message. Yeah, from ICMP. Well done, it's there. So if the port is closed, the protocol says, well, I need to tell you that the port is closed, but UDP does not have flags, so we use ICMP, another protocol. That's crazy. So we say, hey, ICMP, and the protocol exactly is port unreachable. So if the port is closed, we get ICMP port unreachable. If the port is filtered, what do we get? Probably nothing, timeout. So if a UDP port is open or filtered, we cannot distinguish these two states. If it's closed, we can. Of course, unless we speak the protocol. We are going to see that later. OK, so this is searching and finding computers up with ICMP. OK? Then We have the ICMPs, we have the others with PA, yes, a lot. There is a small pro tip that if Nmap is running, you can press D and capital D to decrease and increase the debugging, so you can do that. How are we on the internet? Everyone is fine? Internet? Everything is working, doing stuff? Somebody issues? No? Okay, thank you very much. So let's gonna go to this network. So this is a network on the internet. If you care to know, it's some computers in China. And we are gonna find if they're up or not. So please tell me if those last 100 hosts on the network, how many are up in this moment? So please tell me. Go, try, and tell me. How many hosts in that network are up in the last 100 hosts? $28, $29. Oh. 27. Oh, nice. Another one? We are being blocked super fast, so hurry up. China, you know? Real-time detection. Somebody else? 28. So it varies. Why it varies? What is the problem? Are we doing it wrong? Well, the problem is that maybe you never hear this before, but the internet is not reliable, right? So packets are lost. And in this case, what's going on is that there are so many packets that Nmap, at some moment in time, has to stop waiting. It's like, well, I send you packets. How long am I going to wait for you? So after some time, Nmap is like, yeah, forget it. It may happen that some of these packets are 1 second late going back to you, and Nmap is losing them. So you should also learn to play with the timing in Nmap to say, no, Nmap, you know what? Take your time, wait a little bit more. Oh, don't resend, stuff like that, okay? That's why sometimes we have different numbers. And that's why you should do the test several times too, okay? So now that we are with host apps, let's interact a little bit with ports. So to search for ports, we already talked how to do this. We are gonna be searching for the top 100 ports in that range of computers. That is like 28 computers, and we are gonna be using the parameter capital F, which means fast. Fast means the top 100 ports. So if you run this command, we are going to be now scanning ports. We are scanning people. We are not only looking if the computer is up, we are scanning to see if the ports are open or closed, and we are finding ports. Can you please do this and check that you have the same results or similar results? Yes, we are telling Nmap, scan only the top 100 ports. Don't scan all of them. We are doing this because, so what is the top? Top of what? Can you tell me? Top from the internet? Do you agree with, wait for me. Not Martin, no, you told me. It's not Peter. Okay, tell me. Pavel. So as Pavel is saying, the top of the internet. Do you agree? Yes, no. No. So this is very nice. In the Nmap community, for something like 3 years, they ask the people to submit scans from the internet. So you're right. And you scan, and you send, and then they actually did a statistical analysis of which are the ports that are more probably open on the internet, and they're scanning those first. So for that sorted list of ports, this is the top 100. So the probability of finding those ports opens is very, very high, okay? And here we can see computers having 22 SSH, 443, and this one has 8081, and this one has 53 TCP. Ooh. And then this one, look at this one, a very weird one. What is this? I have no idea. And then some WBT server, and then NetBIOS, and then Microsoft Remote Procedure Call, and then a lot of computers. So we are finding computers, and then we are doing port scanning TCP. Which technique are we using? The technique that we call SYN scan. Look at the S, SYN scan, or stealth. Stealth or SYN means I'm sending a SYN. If you send a SYN ACK, I'm not sending the last ACK. I'm not closing the handshake because I'm smart and I don't want you to detect me. And I don't care anymore, the port is open. So I send a SYN ACK, that's it, you're open, I stop there. That's the stealth scan, okay? So if you do not use the capital F and you just leave it to Nmap, Nmap is scanning the top 1,000 by default, but not all of them, okay? Be careful. So let's do a horizontal scan. This one means I just want one port. Do you see the -P80? So we are searching only for port 80 in that network. Try this one, and we are going to see computers with port 80 open. Okay? Everyone? Yes? Super. Now, if you want to scan all the ports, crazy, all the ports, that means that you are not giving the initial port, and you are not giving the last port in the range, right? Because here you can put a range like port 2 to port 4. If you don't do that, you just put the dash, it means all the ports, the 65,555. So it's like, oh, whoa, again, the movie night. So, thank you very much. I don't know what's going on. And in the case of UDP, if you want to scan UDP, you can use SU, okay? SU. So it's going to find the computers and then the UDP. Can you try this one? Can you try UDP and tell me if you see something? And this is only one computer, okay? Is it running? Huh? Oh, D, yes, there, D. Thank you very much, Mari. D, more, D. Oh, there, see? I can see what's going on. Oh, it's sending packets, see? I can see it in real time. Oh. And now I don't want this anymore, so I do capital D. Oh, decrease. Very nice, thank you. And I can see only the ultra-scan statistics. Okay, so is it running for you? Did it finish? Huh? What? Oh, the ETA, yeah, can be. So why so slow? Is the network not working? What's going on? Anybody? Very well, Milan. And oh, I don't know. Sorry, internet. Halloween is coming. You're good, Ondra. So, are we doing something for Halloween? Like customs? Okay. So, services. Now that we have the ports, UDP and TCP, remember UDP is slower because there is no state in UDP, which means when I'm sending something, I need to wait. So that's a very, very bad thing of UDP. And this is going to mess a lot of your scans, but you have to wait. So let's go a little bit to find services. What is services? Well, services means that if you remember when we were looking at ports before, we actually found some ports, like this one, and it says here HTTP. Is it true? Is the protocol speaking in that port HTTP? We don't know. Wait, and how does Nmap know? Very well. So here, Pavel is saying HTTP should, by standard agreement of the internet, be in port 80. So because 80 is open, I suppose this is HTTP. We don't know, and actually maybe not. So to really find what protocol is being spoken in that port, we need to speak protocols. And that's Nmap technique with SV. SV actually, sorry, not that one. This one, SV, actually is going to go and speak the protocols there is a nice heuristic, not speaking everything, the most probably protocols first, later, and then it's going to show us what really is being spoken there. So now it's scanning a computer, port 8888, 50, 2000. Now it's scanning 6 services, something happening, completed the system. We can press enters to see the statistics, 50% done, 11 seconds remaining. You can press any key, see it exists, 10 seconds. 12 is very, very precise. 16, oh, the problem of having issues with the internet. Well, because the internet can lose packets, right? So then it's recomputing. It's like the GPS of the car, right? We have internet issues. Did it finish for some of you? Oh, probably we are sending 2 penny packets at the same time, right? To China. This looks like an attack. It's not. Oh, wow. Anybody? Oh, there. Oh, no. Oh, 34. This is getting crazy. Let's see with debugging, more debugging, more debugging. Scanning. Oh, it's sending the proofs to different ports. Yes. Thank you. Yes. Sorry, here says 15 minutes, so I'm not sure what you're counting. So let's try one of the computers here that is going to be faster. So I'm going to be stopping that one, and I'm going to be changing the IP to the 147.32.82.28, which is here in the university. And there are 3 ports, and now we are scanning 3 ports. And now, oh, there you go. So I changed the IP because going to the internet was slow, and it's saying, well, this is SSH. Actually, the version is OpenSSH 7.6p1, Ubuntu 4, Ubuntu 5, Ubuntu Linux Protocol 2. 53, it's DNS. Actually, it's Power DNS Technique, Authoritative Server 411. And then the 88 is TCP wrap, kind of behind a firewall, not exactly firewall, but something like that. And actually, we are not going to go here, but Nmap is actually able to find the operating system due to some fingerprints in the packets, and it's telling us, yeah, that's a Linux, and well, that's everything we know so far, okay? So this is a technique you can use to get the packets there. So there are other techniques that I will leave you to play at home, like the scripting. Scripting is a very, 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 very powerful technique. I will let it run. Oh, I'm not sure if it is going to run. I can do probably only 80. Wait, so I can show something. Nmap has internally a scripting language using Lua. Do you know Lua? So you can extend the capabilities. So the community start creating many scripts that you can tell Nmap the moment you find, yeah, look at this. So the moment you find the port, run all the techniques you have, like finding the fav icon, finding the header of the server, finding the title of the web page, in this case, database error. And then you can actually brute force passwords, right? You can do many things. If you want to get crazy, go to look at the scripts of Nmap. It's amazing. There are like almost 500. So now that we know how to see if a computer is up, now we know how to find the ports, TCP, UDP, which version they are running. Let's interact a little bit. How do you connect to some of these ports, and how do you do something? So how do you connect to these ports? How do you send stuff to test the security? Telnet, right? Telnet is not for that, but Telnet allows you to connect to a port and send whatever you type in the keyboard to that port. So it's a common technique, yes. We are going to be using a newer version called NCAT, but it's very similar. What is the problem of using Telnet or NCAT or these tools? Well, that you're going to send the packet like the letter A. But you don't know if the protocol is speaking with letters or if the A has any meaning. So because you don't know the protocol, you're not sure if you can do everything. So I suggest for the protocols that are well known, use the tools that you have. If you have a web page, use a browser, or use curl or wget, wget, or something like that. If you have email, send an email. And if you have FTP, use FTP. But in some situations, we can actually interact. And that's what we are going to be doing now. So we are going to be using a tool called NCAT. NCAT is another very old tool. And this is the Nmap version. So the people in Nmap team create this tool called NCAT. And we are going to be using NCAT to connect to some computer. I will pick our Chinese computer. And then I'm going to pick the port 80. So look at this. I'm pressing Enter. Nothing happens. And then I type something, enter, 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 and saying, oh, OK, bad request. So look at this. HTTP 11/400, bad request. What is this? What is it? It's a response. And in particular, it's an error. No, somebody was saying something there, yeah. No? Yeah, it's an HTTP page error. It's like a web page, let's say, going back to you. If you put this in a browser, well, you are not going to see anything. But it's the answer going to the browser, saying, hey, I'm protocol HTTP 11/400, the error, saying bad request. This is my date. I'm an Apache. This is the content of this. The connection is closed. The type of content is HTML, and this is a web page actually telling you your browser sent a request that this server could not understand, blah, 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 and the server is in the local host. So this is a web page. We are talking with him. So how can we actually speak with them? We can speak HTTP, and for that, we can do get/HTTP 1/1 host. Oh, I was too slow. So if you speak the protocol with them, I will try again. Get, no, HTTP 1/1. I'm too slow. So let's try another one. For example, this one. What is 1111? Cloudflare DNS. But they also have a web page, see? So I want actually to speak. So let's see if I am fast enough. Get/HTTP 1.1 host 1111, and there you go. See? I spoke. I'm a browser. So the minimum HTTP to be a browser is the method get or post, which page do I want, the root, the main page. I'm speaking HTTP 1.1, and you need the host header saying where I'm going. After that, you press enter twice, and this is a valid browser request, and actually it's telling us, oh yeah, 301, move permanently, which means they don't want me in this port. They're actually gonna be resending me to the HTTPS ports. It's like, yeah, I'm not speaking HTTP anymore, encrypt with me, okay? But this is a very nice web page, okay? So before, after doing this with port 80, let's try another one more interesting. That is, let's send an email by hand. These sending emails like Gmails, they're overrated. We don't use that anymore. We send emails by hand. So we are going to connect to the email service of the university, this one here, and we are going to speak the SMTP protocol. So the SMTP protocol starts with the extended hello, which saying, I am, I don't know, test.com. I say, oh, test.com, welcome. Those are the things you can do. The size, start TLS, pipelining, whatever. So after this, and you can see here, we are going to say, who are we? And say, oh, yeah. The mail is coming from Pepito Pipi at here.com, okay? And let's wait to see if it's telling me something. It's not telling me anything. Oh, timeout exceeded. Yeah, I was too slow, right? Okay. Hello, test.com, mail from Sarasa at gmail.com. Okay, the sender is okay. I can be whoever I want. And now I need a recipient. So we need a recipient in here that should be a recipient in an @fail account. Who wants to give me an @fail account? So do you remember the one from Mari? How is it? It's in the document. Where? Oh, look at this. Thank you very much. So thank you, Mari, for doing this. Oh, time out. Wait, I need to be faster. hello@sarasa.com, mail from @gmail.com, and then RCPT to Mari. Oh, no, RCPT to Mari. Thank you, Mari. And now we need to send data, which means I'm sending the email, and my first piece of data is going to be the subject of the email. Ooh, hi. There you go. And now this is the email, right? Hi, Mari. How are you? Whatever you want to send. And to send the email, you need to put a single dot, and that's it. The email is queued in the system, and it's being delivered to Mari. You already have one. Faster than me. Well done. Well done. And then if you want to quit, you quit, and the communication should be broken. So please try. I will give you as much time as you want. No. I will give you 1 minute to try this technique. Send an email by hand.
If Mari gets less than 10 emails, I will be disappointed.
Is it true that you have a filter for us? No? Who is the sender? Anyone in the world, like Obama at whitehouse.gov.cz or whatever you want to put. So why this is happening? Is the world crazy? Can we send email like if this is 1970? So send an email and we will discuss why. Sorry, it says here 5 minutes. Actually, it's frozen, so I still have 5 minutes. The internet? Internet, you can do this from your Dockers, right? No questions. Thank you, Veronica, for asking on the internet. Is the internet there? Oh, yeah. Oh, I have thumbs up. Thank you, Stefan. And we have hearts. You should be fast because this is not for humans, it's for computers, right? So you're like, Yes. Okay, so, yeah. Oh, really? Wow. So, you're receiving so many, you probably want them, right? Okay, so what's going on in here? Well, usually, if you do this with any SMTP server on the internet, you can scan for ports 25 on the internet and try this. Now we are smarter, and we are saying, well, yeah, you are saying that you are Pepito at Gmail. How do I know? So now we have ways of authenticating, and usually you need to be authenticated in the server to say that you are somebody, okay? In the case of the CVUT, if you are inside the network of the CVUT, they are not checking. Don't tell anyone. So they're not checking, which means that, oh, you're in the CVUT network, I trust you. So you go there and you say, yeah, I'm this, and there is no way to tell except your IP address. The moment you have an IP address, it's going to appear in the email so they can see your IP address, okay? So be careful, and remember what we were saying about the last class, ethics, okay? We have some power here. We also have some responsibility. So please don't abuse it, because that's why we are teaching it. So use it, it's fine, it's fun, learn about it, this is nice. It's some powerful technique, okay? So that being said, we are going to be finishing with, we can do this in many protocols like POP. Nmap can do many more things, so you can try at home, like decoy IPs. It means that Nmap can actually send fake IP addresses as source of the packets to confuse. You can fragment packets. You can relay through proxies. You can output and store the output of Nmap in files. Here I have an example of what is, for me, the fastest way to configure Nmap ever. And then we have only the operating system, and the one that I like the most, capital A, which means do everything. Go and do everything you have, OK? In particular, the capital /T is for the timing. You can actually change the timing directly, OK? So that's it for today. Before showing you the assignment of this week, I will take questions from anyone on the internet or here. Yes? You're going to break the internet. No. So you send an email to yourself from your own email. Really? They're watching you. I have no idea. Maybe check it. Maybe it's like a warning email. Really? OK, can you send us a screenshot or something later so we can check? That's weird. Somebody had the same issue? No? Sorry, again? If it can be something? Can't be done in which sense? Technically, legally, ethically, morally? You just did it, so it can be done, yes. That's what you mean? What surprise? Yeah, OK. Because in the 70s, the whole internet was open like that. So we trust the people to tell us what they were. It went bad. So we start saying, oh, no, before sending an email, I want you to authenticate, to put your user, your password. Actually, it's not enough. Now we are checking the SPF in the DNS, checking your credentials, public keys. To send an email, some organizations do not allow this anymore. It's the web or nothing. Use your browser, right? So being able to do this in a port 25 still now, and somebody's opening, is very surprising. If you find this on the internet, actually, if you find this on the internet, the people is selling that for money because it's used for sending spam. So actually, spammers are scanning the internet like crazy, finding badly configured servers, abusing them, sending spam, getting money, and yeah, so that's why. OK, so assignments you want to show? Yes.
Can you hear me? Oh. So for the assignment, you will be using...
Should I scroll?
Yeah, sure. So you should be using your Docker. There is an IP range, so you should be scanning it. Please avoid... Yeah, I'm in the recording, it's fine. Please avoid scanning anything apart from this range, because we will be hearing complaints from the university administrators. You should be finding which devices are up in this IP range and finding which services run in the active devices. There are 2 more questions in the CTFD, so please answer them and find the flag which will be given by one of the devices that are up in the IP range. That's pretty much it. If you have any questions, send us email, send us message in the chat in MS Teams. Yeah, we will be opening it at 8. Before? Oh, sorry. So 7:45 tonight, it will be open. There will be Pioneer prizes again. So go crazy.
7:45. This is official timing because the people is they're gonna stay here waiting.
No, we need to close the classroom, so no.
Oh, okay.
No, but there will be Pioneer prizes starting tonight, 7:45. It will be live.
Yeah, the prices for this are gonna be different. So stay tuned.
Yeah, and last but not least, please give us some feedback on the class, if you could follow or not, if there are any technical issues, so we can improve for the next week.
Oh, yeah, yeah. Remember the cheat sheets of Nmap? Take them. We have unicorns, people. Look, unicorns. You can take stickers. No, you're welcome. They're beautiful, right? Oh, there you go.